Hello everyone. So guys, please confirm me once that am I audible and visible to you? And share your attendance as well. Okay. So guys, what's up? What's going on? And first of all, tell me, how are you? Show me centers, please. Hi Shillong, hi Senapati, Kohima, hi Sisipur. Guys, am I audible and visible to you? Every center? But I can see many students over there at the Shillong center. Hi, good evening, Itanagar. So guys, how is your life going on? Is there anything which is interesting or new, which would you like to share with me? Okay, it's okay. Kohima, Itanagar, Sisepo, guys, kindly share your attendance and tell me the topic that we were discussing in the previous class. What topic we were discussing? Okay. What was the topic? Topic of discussion? Okay, that's good, Senapati. Shillong has one or two right now? Shillong? Guys, please share topic. We'll start with our studies. Okay? Okay. One in one room. I think Shillong has two different rooms, na? Excuse me. Okay, law of chemical combinations. Please tell me, do we have discussed conservation of mass as well as constant proportions? These two laws have been completed. Okay, it's okay. Guys, from where we have to start? What's the topic for today? Do we have complete law of constant proportions? Is this completed? Is this completed? Or yet it has to be discussed? Okay, it's over. I think so we have to start with the Dalton's atomic theory. So guys, let's begin finally with our topic, which is Dalton's atomic theory. Okay, so guys, Dalton, as I have told you in the previous class, that Dalton was the first one who introduces atom to us. Okay, he simply said that the smallest particle of a matter is known as atom. Okay, I think so we have already overcome with the discussion of the Dalton's important points. Okay, it simply says that the smallest building block of a matter is an atom. Okay, if we start dividing a particle, or not a particle, a matter, we will end up at a point where we cannot further subdivide that particle, and that stage is known as what? Atom. Okay, that's whole what said by the Daltons. Okay, so guys, see, according to this theory, all the matter, whether element or a compound or a mixture, is composed of small indivisible particles called the atoms. This theory was based on the law of chemical combinations. Okay, so guys, you can please copy these 2 points, and then we will move on to the next slide. Okay, let's see what interesting after this. And please inform me once after copying that. Shillong has done. What about other students? Senapati, Sisipo, Temenlong, Itanagar, Kohima. Kohima has done. Temenlong. Okay, take your time, dear. Senapati also done. What about you guys? Can I move to the next slide? Okay. So guys, these are the main postulates of the atomic theory. Okay, can please someone tell me what is the meaning of postulates? Anyone? Please, what is the meaning of postulates? I'm waiting. Give me smallest definition, or you can give me synonym as well. Okay. It's okay, Itanagar. Okay, Sisipur has given its explanation. Quite good, very good, Sisipur. Okay, Kohima has also given its explanation. Good. Guys, I need explanation from every center, every student. Can you please help me out? That what is the meaning of postulate? let's figure out the meaning of postulate, because we have to deal with lots of postulates. Many a times you will find out that postulates of Dalton's theory, postulates of the Bohr's theory, postulates of the Rutherford theory, many. Okay, let me start. See, postulate means a theory which is not experimental based, okay, which belongs to the assumptions over there, okay. Ultimately, there is a fact available in this world and we try to prove that fact, okay. So, to prove that fact, the theory which is given by us is known as what? Postulates, okay. Let me simplify this one for you. That basically postulates means assumptions made by us to explain that particular phenomena or the theory is known as what? Postulates, okay. Am I able to clear this word postulate to everyone? Is it clear to everyone, the meaning of postulate? Okay. So guys, there are some postulates of the Dalton's atomic theory. Okay. Tamalong says no. Dear, you can simply say that postulate means assumptions. Assumptions which are taken by us to explain a theory. Okay. These are basically assumptions. We can say that. These are assumptions. Okay. Now is it clear to you? Senapati, Shillong, guys, are you there? Okay, so let's begin. So guys, there are some postulates of the John Dalton. See, 1 second. Yes, guys. So I need your presence. Show your presence. Yeah. Okay, guys. So look at your topmost right hand side of the John Dalton. Atom can neither be created nor be destroyed. I think so. We have deal with that. Okay. This was said by the John Dalton. Then the second term was said by John Dalton was that matter is made up of small indivisible particles called atoms. Already discussion is over on that point. Next, there are a few other points as well, 4 points. Let me discuss one by one. That atom is the smallest particle of an element which takes part in a chemical reaction. Ultimately, the theory of John Dalton was given in reference to the chemical reactions. Ultimately, he gave his theory to just clarify the chemical reactions, how chemical reactions takes place, and ultimately what happens in a chemical reaction. So this theory totally supports the chemical reaction. Okay, he actually observed the chemical reaction, and after the observation he gave his postulates. Okay, so that's why this theory is quite relatable with the chemical reactions. So atom is the smallest particle of an element which takes part in a chemical reaction. Next, atom of same element are identical in all respects, especially size, shape and mass. Okay, so guys, let me clear this point first. See, if I say this sheet is made up of iron, okay, so guys, look at this. This is the matter which is iron. If I talk about the particles, the atoms of this sheet, obviously all the atoms of iron will have definite fixed shape, size and volume. Okay, all the particles of iron will be identical in all respects. If I talk about this sheet, let's say suppose I have another sheet and this sheet is made up of copper. Okay, again guys, the particles of the copper will have identical in shape, size and mass. Okay, but if I talk you about that whether the size, shape and mass of the iron particle would be similar to copper, my question is that is the mass, size, shape of copper particles would be similar to iron? Tell me, will they be identical or not? Guys, are you getting my question, what I am trying to ask you? I'm comparing iron with copper and I'm asking that the atoms of iron and copper will be similar or they will be different. Okay, I have got one answer. What about you guys? Tamenglong, Kohima, Sisipur, Itanagar, Senapati. Guys, what are your views? Am I clear with my question? Is my question clear to you? I am only asking you that whether the particles of iron, where I am saying that atoms of the iron and copper would be same or different. Okay, that's cool. That's what actually a second point means. Okay, the second point. See? Yes, very good. That was actually second point saying that the atoms of same element are identical in all respects. Okay, especially size, shape and mass. Okay, but they will be different when we compared with the different elements. Okay, next. Atoms of different element have different mass, size and shape. So this is the third point that we have already covered and at that concept. Atoms of different element combine in fixed ratio of a whole numbers to form a compound. Guys, look at this very carefully. What actually that point trying to say? I hope so we have discussed, we are clear with the concept of law of constant composition. See, we have seen CO2. What does it mean? That if I talk about carbon and oxygen, carbon has one particle and oxygen has got the two particles. Okay. If I talk about H2O, so look at the hydrogen and oxygen. Hydrogen has got two particles and oxygen has got a one particle. If I talk about Fe2O3, iron has got two particles and oxygen has got three particles. See, particles are actually this one. I am writing these numbers. This is 1 which is written over there. This is 2 which is written over there. This is 1 which is written over there. This is 2, this one and this is 3. Okay. So actually John Dalton was trying to say that we haven't seen these kind of compounds. See, here we are trying to say that Fe has got 0.93 atoms. We know that atoms are what? Countable. They can be 1, 2, 3, 4, 5, 10, 11, 20, 100, 1000, 1 lakh. Okay. We can't say that atom would be half. It will be 1.5, it will be 2.5, it will be 0.2, it will be 0.9. Okay. So John Dalton was saying that they will always combine in a fixed ratio, means it cannot be in the decimal part. Okay. So according to Dalton, this compound is not possible. Okay. If I say AB, A has got 0.5 and B has got 0.2. So according to John Dalton, this is not possible that A can have the 0.5 atoms and B can have 0.2 atoms. Okay. So that's what the final point means. Is it clear to everyone, the meaning of the final point? Or anybody has got some doubt or confusion? Anyone has got any doubt or confusion? You can ask me, guys. Okay. What about others? Guys, you can please copy this one. Please copy this. Yes, tell me, Tamenglong. Tell me. Please copy this, and after that Just inform me that you have copied that. Guys, am I speaking too fast, or is it comfortable to you on this current pace? Are you comfortable with the current pace? Okay, good. Hey Shillong, okay. Shillong, Tamelong, Senapati, Sisipo, Itanagar. Guys, are you getting me? Okay. Guys, please do reply as soon as possible. I'm still not getting responses from the Itanagar, Shillong, Tamelong. What happened, guys? Yeah, sure. In the last point, it is saying that atom of different element combined in the fixed whole number ratio. See? Is 0.93 a whole number? Whole numbers are what? Which are not in decimals. Okay? So, as we can look at this compound, 0.93 is not a whole number. So, according to John Dalton, this compound should not formed. Okay? Because in this, iron is not combining with oxygen in the whole number. It is combining in the decimals, in the fractions. So, according to John Dalton, it is not possible. Okay? This is the meaning of the last point. Is it clear to you now? Okay. Senapati, is it clear to you? Shillong, have you copied that? See guys, if you don't reply after repeatedly saying that have you copied, then it would be very difficult for me to manage. Okay, if you have got any doubt, any confusion, you can revert over there, or if it is clear to you at that time as well, you have to revert. Okay. So guys, this is the activity for you. See, some postulates of Dalton's atomic theory reinforce the laws of chemical combinations. Identify the Dalton's postulates that are based on the law of conservation of mass, law of constant proportions, or none of these. Okay. So guys, first of all, please copy this one, and then you have to mark. Let's say suppose all the matter is made up of very tiny particles called atoms. Okay. So you have to just confirm that whether this statement is based on law of conservation of mass or law of constant proportions, or it does not belongs to these two statements. Am I clear with my statement? That what you have to do? You have to read the statement and you have to just check that whether the given statement follows either law of conservation of mass or constant proportions. If it does not follow both the statements, then you will mark the none of these, which is n. Okay. Please copy this and mark your answers, and after that we will discuss about it. Please start writing this. And after copying that and attempting all these questions, please inform me once. And guys, tell me, are these chapters have been completed in your schools? Or how many chapters you have completed in your schools? How many chapters you are done with in your schools? All the chapters you have done? Okay. That's good. Very good. Okay, after this question, we will talk a little bit. Okay, we'll talk to each other. So every center and every student, please be ready with your questions. Okay. First, I'll give you a chance to ask questions to me, and then I'll ask you a few questions. Okay. Questions will not be from the syllabus. Okay. Just another intro to each other. First of all, let's complete this question. And confirm once that Shillong, Kohima, Itanagar, show me centers please. Centers once. Sisipur, Itanagar. Okay. Sisipur, Itanagar, Kohima, Senapati, Shillong and Tamenglong. Senapati is there, Tamenglong is there, Kohima is there. Shillong, Itanagar and Sisipur. Guys, kindly confirm that. Are you there? Confirm once. Okay, that's good. Oh, sorry Shillong, I haven't got you. Can you please repeat this again? I mean, what you were trying to say? Guys, have you copied that? Are you done with that? Can we start? Okay. Okay, it's okay, dear Itanagar, no issues. Bingo. Okay, so everyone is there. So guys, let's begin. I'll show you the answers. You have to just quickly check out your answers and then let's see. How many of you has got the all the correct answers? So guys, here are the answers. Please cross check once. And tell me who has got the all right answers. Who has got the all correct answers? Hey guys, have you checked that? And please tell me whether is there any point which you want to discuss, any point where you think that we need to discuss about this one. That's good. What about rest of the centers, guys? You can reply. Itanagar, Tamelong, Shillong, Sisipo, Senapati. Okay. Any point of confusion or doubt? So guys, please first of all tell me quickly that any point that you want that I should discuss with you, any point where you got confusion or you think that this is not according to your answer. If not, then we can move on. Okay guys, so that's all about your Dalton's atomic theory, and after that the drawbacks due to which Dalton's atomic theory got failed. Okay, look at the first drawback. Please do not copy this. Let me first clear it to you. What is the meaning of these statements? First statement said that subdivision of atoms are subdivision of the atoms. Atoms are further subdivided into protons, electrons and the neutrons. Yes guys, as said by the John Dalton that we cannot divide atom further. Means atom would be the smallest particle. But guys, unfortunately, when scientists started experiment on the atoms, when they start observing it, they come to a conclusion that atom can also be further subdivided, and though after the subdivision atom will contain the three sections, not sections, three sub particles as well, which are known as the fundamental particles as well of the atom, which are electron, proton and neutron. Actually these are the smallest particle of a atom, not the atom. Okay, so atom can also be further subdivided. So this was one of the issue with the Dalton's atomic theory. Second point is isotope. See, atoms of same element can have slightly different masses, and these are known as isotopes. Okay, for example, carbon have three isotopes: C12, C13, C14. Okay, so one important thing over there, that guys, carbon 14. See, carbon 14. Can you see this symbol? This is, see, how do we read this? This is C12, okay, also written like this, C12, they both have the same meaning. This is your C13, this is your C14. Guys, you can remember one important thing over there, that C14 is reductive in nature. Okay, you can copy this one. Okay. Other than that, one second guys, 1 second, I'll give you time to copy that. Let's move on to next postulate first. Then isobars. That atoms of different elements that have the same atomic masses are called the isobars. There are few pairs, or we can say many pairs are available to us whose atomic masses are same but atomic numbers are different. Guys, there is an error here. Okay, in case of isobars, see, one second. This is the pair of isobar, not that one. Isobars are those elements which has got a same atomic mass but different atomic numbers. Okay, like argon has 40 atomic mass but atomic number is 18, whereas the calcium has got atomic mass 40 but atomic number is 20. Okay, so guys, in the example you will copy this one. Okay, not that example, you will copy this one. Okay, first of all, please tell me, are you clear with those 3 points? Are you clear with all those 3 points? Anyone wants me to repeat or take some other examples as well to explain those 3 examples, those 3 particular points? Or can we move on? Okay. Which point, dear? Which point? Okay, I'll start with the isobars. Okay. Guys, please take a look. I'm repeating the isobars. Guys, ultimately the drawback was it could not explain the isobar. Okay, means the phenomena of the isobars was not explained by the Dalton's theory. First of all, let us understand what is the meaning of isobars. Isobars means atoms having same mass Please do not copy this, only we have to understand this. Atoms having same mass but different atomic number. Guys, one thing that we are not seen many elements till now, okay. In the next slide we will look to many elements, okay. So till then just remember the examples which I am giving to you, okay. So look at this. Calcium is atomic number 20. See, at the bottom we write the atomic numbers, and at the top we write the masses. This is the mass. So if I talk about calcium, the atomic number is 20 but the mass is 40. If I talk about argon, atomic number is 18 but mass is what? 40. So guys, look at this very carefully, that calcium has mass 40, argon has also got the mass 40, but look at the atomic numbers. It has got atomic number 18 and it has got atomic number 20. So this is a pair where masses are exactly same but the atomic numbers are not same. So all those pairs where this condition satisfies, that masses should be same but atomic numbers should be different, will be known as what? Isobars. Any available pair. Let me take another example. Look at this. Let's say suppose tell me, are they pair of isobars? Are they pair of isobars? Tell me, are they pair of isobars or not? Okay. Hey guys, Itanagar, Sisipur, Temelong, where are you guys? Oh, Sisipur, okay, Sisipur is there. Kohima, are you there? Itanagar, Senapati. The question is, are they isobars? See, for the isobars, what do we have to check? Yes, okay, that's good. So guys, please do reply. See, you have to check this one. If these numbers are same, if these numbers are same, these are masses actually. See, same mass. They will always be isobar. Okay, I hope so it is clear to everyone. Let me check another, let me give you another example. Look at this very carefully. Tell me whether the given pair are isobars or not. Tell me, are these isobars or not? Okay, I have got one answer. Congratulations. Oh wow, much more clarification. Good. Well done, Sisipo, Senapati, Shillong. Hey, what about you guys? Kohima, Itanagar. What are your views, guys? What do you think about it? Are these pairs isobars or not? Okay. Yes, guys, definitely these are not isobars. Okay. Because look at the masses. See, they are different. That's why they are not isobars. Okay. Okay. Let's see, guys. Okay, this time I'll take name of only that center who give answers fastest. Okay. Only first one will be counted. Please. Your finger should be on the keyboard. Okay. Then the question is, You have to identify the given pair whether will be isobar or not. Okay. So are you ready, guys? See. First, question is for the isobars. Okay, for the first question, Shillong has got the quickest answer. For the second one, Sisipur has got the quickest answer. And what about other students? What are you doing, guys? Kohima. Kohima, are you connected to me? Okay, that's cool. So, now is it clear to everyone what is the meaning of isobar? Do you need any other clarification on this one? Okay. So guys, now you can please copy this. Please copy this. The drawbacks. Okay, okay, it's okay, dear. Bingo. Good. Please copy this and just inform me. And guys, please, in the example of isobar, do not copy this example. Do not copy this example in isobars. I'll shift to the next. Dear, that is misprint over there. That's why I've told you that please do not copy the example of isobars. I'll shift to the slide where I have written examples for you. Please do not copy this one. In case of isobars, there is a printing error. Just intimate me once after copying this. I'm repeating, please do not copy examples of isobars. I'll shift to the another slide where you can write the examples. Please do not copy from the current slide. Examples of isobars only. Kohima, is there network issues going on? Okay, you have done with that. Cool. Please copy these examples. Please copy this one. You can copy this one as well. Copy these examples. Good. It's okay, dear. Take your time. Do I need to switch to the slides? Come along. Okay, okay, okay. Give me 1 minute, please. Guys, please, those who has copied the whole drawbacks of Dalton's atomic theory. Please copy these examples. Give me 1 minute, dear. After that, I'll shift to that slide. Okay. Please, you can copy now. Hey, welcome Tetsu College. Are you there? Can you hear me? It's okay, dear. Plus, please try to be on time. Time along, please confirm once after copying that. And what about others, guys? Have you copied that? Kindly confirm once that you have done with that. Okay. Okay, guys, so let's move on to the next one. Guys, can you solve this question for me, please? Please solve this question and tell me the answer. If water contains 1 part of hydrogen and 8 part of the oxygen by mass, then what will be the percentage of oxygen in the water? Please solve this one for me and tell me the correct option. What should be your answer? Okay, I have got answers from 2 centers, 3 centers, very good. Okay. Okay. Okay, so let's move on to the solution section. Answer is C, 89%. Any confusion? Do I need to solve this? See, let me solve this one for you. We have got, we have got hydrogen 1, oxygen 8. They are asking the percentage of oxygen. So 8 upon 1 plus 8 into 100. So this one should be 8 by 9 into 100. So this one is 800 by 9. So on solving, I guess so it will be approximately 89%. Not exact 89, but this one should be approximately 89%. Please copy this solution for those who haven't got the right answer. But most of you has got the right answer. And those who haven't got the right answer, I think so there is a minute calculation error. Only the minute calculation error. So guys, please be careful regarding the calculations. Over. Okay. Guys, please look at the question. Copy this question. Tell me the answer. What can be answer for this one? First of all, please copy this question and then you have to tell me the answer. And after this, we'll take a break. And after that, we'll continue. Have you copied that, Shillong? Please don't be in so hurry, guys. Relax. Please copy question first. And then you have to tell me the answer. Okay, very good. Hey, Kohima Tetsuo College, Itanagar. Yes, guys. Very good. Itanagar, what do you say about this question? Tetsuo College, Senapati, Sisepo. Very good. Hey, what about other you guys? Itanagar, what do you say, dear? Sisipo? Have you got the answer? So guys, let's look at the solution. Answer is law of conservation of mass. See guys, this is a quite simple question. In the question, they are saying that in an experiment, 10.6 gram of sodium carbonate reacts with the 12 gram of ethanoic acid, which are reactants actually. Okay. Produces 4.4 gram CO2 and 1.8 gram of water along with the 16.4 gram of sodium ethanoate. Guys, just sum up the total reactant masses and the total product masses. If they are equal, it means that they follow the law of conservation of mass. Are you clear with the solution part, or do I need to solve this for you? You have to just sum up the total masses for the reactants and the products. You will get your answer. That's what you have to do. Guys, please do reply once if it is not clear to you. See, if you won't reply, I won't give you a break. You want break? Dear, constant proportions is valid for the compounds, not the reactions. Please make this one clear that this one, constant proportions is valid for the compound, not the reactions. So if you want a break, then you have to reply. Please tell me, who has got still confusion in this one? If you have got confusion, then we'll discuss it first. I need reply from everybody. Is it clear to everyone? Okay, that's cool. Tetsuo, Kohima, Tamenlong, Shillong, okay. Good. You have given the right answer. Very good. Okay, guys. So, guys, this is the summary. Look at this once. What we have discussed and this one till now. That conservation of mass says that total mass of reactant should be equal to total mass of product. Definite proportion says that in a chemical compound, elements will be present in a fixed proportion. And then the last point is element is made up of same type of atoms, and as well as the smallest repeating unit of a matter is known as what? Atom. So that's all we have discussed till now in the first PPT. Okay. So this is the whole summary for this one, guys. Okay. So let's take a break of 7 minutes. Okay, no 5, no 10, 7 minutes. Okay, 10 minutes of break, and we will continue after that. Okay, see you after the break. Hi guys, back again. So guys, how was your break? Was it refreshing? How are you feeling now after your break? Am I audible and visible to you? Hi guys, can you hear me? Or are you still on a break? Itanagar, Tamenglong, Senapati, Sisipo, Shillong, Tetso, Kohima. Hey champs, are you there? Okay, what about you guys? Please look confirm once. Whether am I audible to you? Okay, that's good. Two are there. Yeah, that's really good. So guys, oh wow. So it's your turn, guys. Let's talk something. Yes, I am. Okay. So guys, let's talk something. Okay. So anything interesting that you want to be, or you want that topic or that thing should be discussed in the class, other than these studies. For the next 5 minutes. After that, we'll get back to our studies. Okay. Tell me. Or you have a choice. We can continue with this, our studies as well. What do you say? No one is interested. Guys, okay, tell me, talk versus studies. Choose anyone and majority will win. Shillong, Kohima, Tamenglong, Senapati, Tetso, Sisipo, valency. Okay, let me simplify valency for you. Valency is the charge present on any species. Okay, talk. Okay, we will talk. Okay, let's have a question round. You can, I'll give you a chance to ask me questions. Okay, I'll give answers to a question. I'm very good at giving the answers actually, so that's why I have chosen that section. Answer section will be for me, question section for you guys. Okay, Shillong, let me clear your doubt that valency. Tamenglong, please give me 1 minute. 1 minute. Let me answer first question. See, valency is actually charge. Let's say suppose Na plus. Here charge is +1, therefore valency is 1. Cl minus, -1 charge, the valency is again 1. Okay. SO4 2 minus, valency will be 2. Mg2 plus, valency will be 2. Al3 plus, valency will be 3. Okay. I hope so it is clear to you, Shillong. Have you got the meaning of valency? Okay, so let's start. Okay guys, so this is the questionnaire round. I'm giving you a chance. Okay, I have got one question. Okay, my favorite subject, maths as well as chemistry. I'm quite interested in maths as well. So maths and some chemistry are my favorite subjects. Next please. Is that over? +1. Gold is +1. Two more minutes. Sorry, I'm not getting your question, dear. Tamalong, can you please repeat this? Dear, uranium is an radioactive element. Uranium is a radioactive element, so we can't identify its valency. Hey guys, you are too slow. Might be there is network problem. Is there network issues, guys? If yes, then we can continue with the studies. If am I audible and visible to you, then we can continue with the studies. We can have the conversation some other day as well. It's because we have lots of time. Can I start? What do you think? Tamalong? Yes, I am a teacher. Hindi. Okay. My question is, can we start with the studies? Okay guys, so let's start with our studies. Okay. Okay. Guys, this is a recall test for you. Okay, you have to just answer these questions. Okay, quickly. 5 questions, 5 minutes, 5 answers. Start. And then we'll see how many of you has got all 5 correct answers. Need not to reply on the screen, dear. You can just write answers in your notebook, and after that, let me complete, dear. Just note down the answers in your notebook, and after that, I'll discuss each and every question, and then we'll check. Okay? Just revert me on the screen that you have done with all the questions. That's it. Hey, by the way, Tamalong, why did you ask that question? Do you think that I'm someone else or something else? You can write your views. Guys, I said please write the answers in your notebook, and when I'll start discussing it, then you have to cross check that how many questions you have got correct. Okay, Koima has come up with all the answers. Two more minutes, guys, and after that I'll start discussing it. After cross-checking the answers. So guys, that's it. Here we go. Look at the answers, please, and then check out. Oh, hi Itanagar. And check how many of you has got the correct answer. All the correct. C. And please tell me the question that you would like to discuss with me. Yes, Itanago. Please cross check once. Okay, good. Okay, that's good. I'm not getting your point, dear. Shillong, can you please write it again? Means clearly what you want me to ask. Very good. Guys, please now write the question that you would like to discuss with me. Write the question number that this question should be discussed. If no question is there that you don't want to discuss any question, then we'll move on to the next slide and we'll continue with our syllabus. Okay, I'll do that. See, law of definite proportion was proposed by, answer is A. Dear, this is just name of the scientist. Joseph Proust was the scientist who gave that law. Joseph Proust was the name of the scientist. See, John Dalton doesn't give any of the law. Remember, these laws were not given by the John Dalton, but John Dalton given his theory by keeping in mind these laws. Ultimately, he was trying to prove these laws correct. Okay, these laws were absolutely correct. So he was trying to give his theory with respect to these laws. Okay, these laws were not given by the John Dalton. Okay, John Dalton said about the atom, that what atom is. That statement was given by the John Dalton, that the smallest indivisible particle of a matter is the atom. Okay, laws were not given by the John Dalton, so please don't be confused with that. Okay, please tell me any other question that you want me to discuss. Any other question, dear? Can I move on to the next one? Okay, let's move on. Okay guys, so we will again start with the atom. Okay, see, this is the little bit explanation regarding the atom again. See, atoms are the smallest particle of an element that can take part in a chemical reaction. Okay, atom are the basic building blocks of an ordinary matter. Atom can join together to form molecule which turn to form the objects around you. Atoms are composed of particles called protons, electrons and the neutrons. I don't think so that anything which is written over there need to be discussed. Okay, so guys, you can please copy this point. Okay, further few more information regarding the atom. I think paragraph number 2 is a little bit much more modified form of the atom. Okay, so guys, please do copy once, and then we will start, or we will shift to the next slide. Done? Anybody wants to ask me anything regarding this one? I guess so. This has been discussed many a times. Please do not copy the diagrams. Do not copy the diagrams. I'll try it here. Can you move on to the next slide? Okay. So guys, this is a flowchart of the atom, means all the information that we have collected till now is in front of your screen. Okay, whole information which we know about the atom. See, atoms are the building blocks of all matter. Very true. Size of an atom is indicated by its radius. Okay, this is a quite new, that we do not have any information regarding the size of the atom. We will discuss about it later on in the higher classes. Till then, you can just remember that the size of atom is indicated by its radius, and guys, this radius is calculated experimentally. Okay, and radius of atomic radius is measured in nanometers. The value of nanometer is written over there, that 1 nanometer is equal to 10 to the power minus 9 meters. Okay, hydrogen is the smallest of all. Till now, the elements we have got in the nature, hydrogen is the smallest one. Okay, the size of the hydrogen is given to, guys, need not to remember that value of the size, that hydrogen is 0.037 nanometer. If you can remember, that's good, but that's not our concern that we have to remember these digits. Okay, after that, atoms are very small in size. Atoms cannot be seen ever under the most powerful optical microscope. Yes dear, that is true. Okay, that atom are so small that we cannot see them even by the help of most powerful ultra microscope as well. Okay, but nowadays the technologies we have got are actually of kind that we can visualize the atom. Okay, but there is no confirmation yet. This is the reality. Okay, please copy this one, and you're most welcome that if you want to ask me any question regarding this one, any query, any point, any question that is just got developed in your mind, that you think so that this should be asked to me, you're most welcome if you want to ask me anything. And before that, please copy this. And after copying this, please guys inform me once, so that we can proceed. Kohima, Itanagar, Tetsu. Guys, are you still there? Sisipo as well. Okay. Guys, please inform me once after copying this. And any question that you want to ask me. And guys, please confirm me once that is this pace correct, or am I little bit fast, or am I little bit slow? You're most welcome with your thoughts. Or we are working on the correct pace. You're comfortable with this one. Cool. Everyone can reply, guys. Tetsu, Kohima, Shillong, Tamenglong. Okay, Tamenglong is also already there. Itanagar, Sisipo. Ultimately, guys, you have to be comfortable. Okay. Okay. Guys, have you copied that? Okay. Cool. So guys, subatomic particles of an atom. Ultimately, in this section we have to just remember the few names: electrons, protons and the neutrons, as well as the charges present over there. See, as said by the John Dalton, we cannot subdivide the atom, but after the discoveries and after the performing few experiments, scientists concluded that no, it is not true that atom cannot be further divided. Yes, we can divide the atom, okay, and thus on subdivision of the atom we will have the electrons, protons and the neutrons which are present inside the atom. Okay, so actually electron, protons and neutrons are the fundamental particles of an atom. See, atoms are made of three different type of subatomic particles, also known as the fundamental particle: electrons, protons and the neutrons. Protons and neutrons are found in the nucleus. Guys, nucleus is the section which is the center of the atom. Okay, in the nucleus we will find two things: neutrons and the protons that are present in the nucleus. And other than the nucleus, on the other section of the atom we will have the electrons. Okay, see, one more important thing, that protons and neutrons are found in nucleus and also known as the nucleons. Nucleons means protons and the neutrons. The nucleon word has been derived from the two different words, protons and the neutrons. The collective word for the protons and neutron is a nucleon. Nucleus is a positively charged, reason being that proton has got the positive charge and neutron doesn't have any charge, so there is net positive charge. Okay, nucleus is positively charged because protons are positively charged and neutrons are electrically neutral. Okay, electrons are negatively charged and move around the nucleus in specific orbits. Okay, so guys, you can please copy these points along with this diagram. Okay, the center where you can see a few white balls along with the red balls, those red balls are representing the proton. See, plus symbol is written over there that represents its charge, whereas white balls doesn't have any charge. It means these are neutral and they are the neutrons actually. And after the outside the nucleus we have got the electrons which are represented by the green balls and have a negative sign over there that represents that they have got a negative charge. Okay, what about mass? Dear, mass is only because of the neutrons and the protons. Electron has negligible mass, so it does not contribute anything regarding the mass. Remember guys, mass of atom is because of the neutrons and protons only. Okay, electron has very less mass, that is negligible, so we do not consider that. Okay, mass of an atom is calculated, or we can say considered, only just because of the protons and the neutrons. Protons and neutrons are responsible for the mass, not electrons. Please copy. Any point which is still not clear to you? You want some other explanation on that one? Some other example as well? You want me to throw some or more light on the particular topic or particular point? You guys please, you can ask me. See guys, I'm very much happy when I see your replies on the screen. Okay, so please guys do reply, it keeps me motivated. Okay, okay, that's good. Please copy this once and just inform me that you have copied that. Guys, it might be possible that due to some network issues as well as it is quite difficult to type along with the class on the computer. Okay, so I know little bit problematic thing, but I want that please do that. Okay, give the short replies. Okay, yes, no kind of a replies. That is very much important for me. And please inform me once after copying this. Okay. What about others? Tamelong done, Senapati done, Shillong, Kohima, guys, what's happening? Sisipo, Itanagar, Tetso. Have you done that? Can I shift to the next slide? Okay. So let's move on, guys. So I think so that I am considering that nobody has any doubt. So that's why I am shifting to the next slide. Okay. Guys, this is the little bit on a different section over there. See, symbols of elements, guys. The symbols we actually see right now. We haven't started with those symbols. In earlier age, we used different symbols for the representation of an element. And guys, for the examination point of view, you should remember these symbols. Okay. So these symbols were actually designed by the Dalton. Okay. But they were not quite successful over there because these are very complex and very difficult to remember. Okay, so these were discarded after some time. Okay, see, Dalton was the first scientist to use the symbols to represent the element. So symbol of an element represented by, symbol for an element represent the element as well as one atom of that element. Okay, look at the screen, guys. See, circle with a dot at the center represents the hydrogen. Then a circle with 3 sections represents the phosphorus. Look at the copper. See, at the center C is written over there for the copper. For the gold, G is written at the center, having a few not dots over there in the sideways. There are few lines. Okay. Carbon is simply a sphere with a grayish kind of color over there. Sulfur with the plus sign, lead with the L, platinum, which is platina at that time, was P, then oxygen, then iron, then silver, then mercury, guys. So these are the guys first symbols that we have seen at a very early age. Okay, so you can please copy this one. You have to just remember this. This is there is no point of discussion over there. You have to remember this. Okay, in the next class, guys, there will be oral test as well. Okay, and that test will be among the centers. Please copy this and just inform me after copying this. Please do that. Please do this. Yes, dear, you have to draw. Guys, you have to draw all these symbols. Please draw all these symbols. These are important for your examination point of view, as well as for your knowledge. And after doing that, please inform me once. Is there anybody who is feeling sleepy in the chemistry class? I mean, in my class? Guys, please draw these symbols carefully. Draw these symbols very carefully. You have to remember only these 12 elements. Good. Okay. Temlong done, Kohima done. What about other guys? Okay, so that's good, guys. You have done with that. So let's move on. The modern symbols of the elements. Okay. So guys, in the modern symbol, we have to remember a few important points. That if that symbol, if the symbol of the element has only a one letter, then it will always be a capital letter. If the symbol has two letters, then first one will always be capital and second will always be small. Okay, you have to remember this one, that first letter will always be capital and second will always be small letter. Okay, see, the symbol of an element is first letter or the first letter of another letter, English name or Latin name of the element. Okay, this is just for information, guys. Okay, if the symbol has only one letter, it should be written as capital letter. If symbol has two letters, then the first letter should be the capital letter and the second should be the small letter. So this is just a information for you guys. Okay, let's move on to the next slide. You can copy second point number 2 and 3. Oh, you can copy all 3 points. You can copy all 3 points. Okay, ultimately in the examination they won't ask you that how do we write, what are the rules to write that symbols of the elements. So we need not to write like this, that the first letter should be capital, second should be small. This doesn't ask me an examination, but yeah, for your knowledge it is important. So please copy this one. Please copy this one just for your notebook. Ultimately we have to remember the symbols. That's it. We have to remember the symbols, and we will deal with few important elements. Okay. See, till now total we have got 118 elements. Okay. So we will discuss a few of the elements out of 118, and when you will go to the higher classes, when in class 11, then you will got a trick to learn all those 118 elements. Okay, then your knowledge will be very high. Okay, first of all, copy this one. Done? Okay. Guys, these are a few important elements, okay, that we have to learn. Sodium is represented by the Na. See guys, you will find out that in the few elements, the rhyming of the element would be matching with the name of the element. I mean, a symbol of the element would be matching with the name of the element, but in the few, this pattern won't be observed. Okay. No, we can't. Guys, what I'm saying? Okay, dear. Till now you know the 20 elements and their symbols, and I'm sure that we would be able to learn about 50 elements. Okay, don't worry. So guys, what I was saying that sometimes you will find out that, for example, aluminium, that first two letters of the aluminium are simply written as a symbol. But look at the potassium, it starts with the P, but the symbol is K, different. Okay, so guys, this is just the fact that few elements has been derived from the Latin or the Greek names. So their name is different in Latin and the Greek. This is written in the English over there. Okay, that's why they have got the different symbols. So first of all, you have to copy these elements. Guys, please do copy these elements. Sodium represented by the Na, and this is a homework for you guys. By the next class, you should remember all these elements which is written to you. Okay, please copy this once and just inform me. Sodium is Na, magnesium is Mg, aluminium Al, potassium K, calcium Ca, chromium Cr, manganese Mn, iron is Fe, nickel is Ni, copper is Cu, zinc is Zn, silver is Ag, platinum Pt, gold Au, hydrogen H, oxygen O, fluorine F, chlorine Cl, bromine Br, iodine I. Guys, remember that is iodine looks like in a small letter. Please make it I. Iodine is represented by the I. Don't write it like a L. That is I. Carbon is C, sulfur is S, phosphorus is P, silicon is your Si. Please copy. Guys, remember that iodine is written by the I. And after copying that, please just inform me that. And guys, remember that we have discussed till slide number 10. And guys, be careful while writing the symbols of the elements. Please be careful, don't be in hurry. I am repeating again that iodine is I. That is also I written over there, but please don't be confused. And remember, you have to write the capital letter, not the small letter. Write the capital letter. And confirm once when you have copied that. Confirm once please after copying that. Not right now, dear. You need not to remember atomic numbers right now. You will deal with the atomic numbers in class 11th actually. It will be introduced in the class 10th as well, okay. but the major use is in class 11th, not in 9th and 10th. Yeah, definitely, dear. I'm telling you, you would be able to learn all 118 elements along with their atomic numbers and their name. Okay, Kohima is done. What about you? Senapati, Tamelong, Shillong, Itanagar, Sisepo, Tetsu. Guys, have you done that? Total 118 elements are known till now. Dear, we have to just memorize these representations. We have to memorize all these symbolic representation. Okay, that's good. So guys, okay, so that's it. So my dear friends, my students, so that's all for today's session. Guys, please do remember that please do memorize all these elements, their modern symbols and as well as the Dalton's symbols. Okay, by the next class there will be a test for you. Okay, you have to write the symbols for the elements that I'll pronounce in the next class. Okay, that will be test, oral test as well. So guys, 92 dear, Tamelong, answer is 92. 92 elements are naturally available to us right now. Rest are the man-made. Rest are the artificial. So guys, that's it for today's session. So see you next time guys. Till then, take care. Bye-bye. Have a great time. See you next time.